Hello, everyone. It's my pleasure to be with you all today, and welcome to Brownian Labs. My name is Mohammed A. I'm an undergraduate researcher at the Will City or the Will University of Science and Technology in Egypt, and I'm a co founder of Brownian Labs. I'm studying computer science and AI, and welcome to our first course from Brownian Labs, which is Linear Algebra Declassified. I will talk about briefly about Brownian Labs, and Brownian Labs is a research initiative that is aiming to bridge the gap between the quality of the research and the researchers and the MENA region and the quality of the research and the research that's going on in the Ivy Leagues or the top universities in the North America, which is the US and Canada. So I believe that there's a huge gap, and we are in the Middle East. We are suffering from this gap. We don't have like high quality research. We don't have any novel products that is originated from the Middle East or from the MENA region, and thus Brownian Labs is aiming to build the first deep tech almost in Egypt and the MENA region in the different fields of AI and computer science in general. So we are targeting the almost the applied mathematicians, computer scientists, statisticians, engineers, whether electrical engineering or computer engineering, computer scientists as well. So our main goal is to show how linear algebra or the foundations should be taught in the age of AGI. I believe that there's a huge and perfect resources on YouTube or lecture notes or textbooks, but I think it's not customized enough for AGI. The way we are learning in AGI should be totally different. I believe linear algebra, for example, as it will be our first course in course series, which will be later on introduced, I believe linear algebra should be treated differently. And I'm always saying math has entered the lab. Math is becoming more experimental than it's just a pure math or some formulas or some proofs. No, it's totally different now. I believe through my work in different universities, different research groups, different research topics even, and there is a huge gap between the undergraduate math that has been taught in the different universities and different institutions and the math conducted in research and used in the AI research, and specifically in the industry, like OpenAI, like Anthropic, Palantir, Citadel, Jane Street. Those are using totally different approach for mathematics. So I believe treating math rigorously with application driven, with systems driven approach, as I was saying, like helicopter flight point of view, like in linear algebra, they are starting with matrices and just some matrices multiplication and determinants calculations, but those messy calculations, it's not expressible or it's not meaning something. So I caring mainly about the the same level of rigor plus applications, applications in the industry, case scenarios, business scenarios, how the concepts of linear algebra can be translated into money. And as we see in DeepSeek model, for example, they have used GRPO, which is an optimization technique. Uh, and their models cost almost $60 million. OpenAI billions and hundreds of billions of dollars. So optimizations, math, it's all about math. then the game of optimization and math will never end. So I believe the real engineers, the real scientists, should treat math rigorously and know the applications. Plus, know how to code it. If you cannot code it, you are not you cannot understand it. Okay, so coding the algorithms in linear algebra, for example, or in math in general, is very, very important for undergraduates. I see my undergraduate colleagues are suffering in they are very clever, they are very brilliant in matrix calculations, but once they are asked for translating the algorithm like row reduction echelon form, row reduction or Gaussian elimination algorithm into a code or C++ code, they cannot perform that task. So, in my opinion, linear algebra, as an example, should be treated differently. We will introduce rigorous mathematics plus case studies, which would be really interesting, I believe, from a systems engineering perspective, from industry perspective. Um, Plus, we will code the algorithms, and there will be projects according to the lecture content. So I believe this approach will be huge. Will fill the huge gap between the dry concepts of math and the real work, the real life applications in the industry and in research as well. I believe this will have a high impact. I hope it's like a revolution in mathematics education in the MENA region. You will see, inshallah, a lot of concepts that will be treated differently. In our course, we will not start with the traditional starting point, which is matrices and systems of linear equations, and no, we will start with the definition of linearity. And linearity is existing to solve the fundamental problem of nature, which is the nature is non-linear, nature is curved. How to deal with curves? This is a problem of linear algebra, and thus we have invented linear algebra. Differentiation itself, it's a concept of linear algebra. Differentiation is a linear operator. Um, so the definition of linearity itself would be introduced, and this is the first concept from my perspective should be introduced, is the definition of linearity. What does we mean by linear algebra? Is there a non-linear algebra? What are the types of algebra? What is the difference between linear function and affine function, and the applications of this in industry and data-driven fields like mathematics, statistics, applied math, pure math, computer science, electrical engineering, and so on. So I think it will be a very interesting course. The first lecture will be posted soon on our YouTube channel, attached with the lecture notes as well. Thank you all, and I hope you are enjoying the course, inshallah, soon. Thank you. Happy learning.